Well, alrighty, let's start cruising through some functions and function tables here. Module 5.2. You will be able to generate function tables from function rules and use a set of ordered pairs to graph the function, blah, blah, blah. All you need to know is that you're going to be dealing with tables and use the rules to graph. Okay, that's what we'll be doing today. Alright, so if I look down here at this particular learn, the learns are all the key points that we have to be able to hit, in case you haven't figured that out by now. We talk about a function table. This is a function table. Essentially, it has inputs and outputs, and it helps organize everything for you. Again, generally, what I want you to do with most functions, want to have three ordered pairs. The book will have 4 or 5. I just want three ordered pairs. I want one negative number. Always use 0 and one positive. For the most part, okay. So you want to do negative, 0, and positive. What the rule is the equation. So I could choose my x. Don't forget, my inputs are my x values. They are the independent variables. And what I always say, I write, you write, I write, you write. They're the x values of the independent variables. And they are the inputs right here. They're also our domain. Our y values are the range. I'm just going to go in order with that. They're the dependent variables. And there are outputs. Oh, outputs. Y values, range, dependent. Got it. I got the output right there. Okay. That's what you have to know. So if I put in something, I put in 1, I put that into my rule, what comes out? Well, 2 times 1 is 2 plus 3 is 5. So what I put in and what comes out. So I would graph the ordered pair 1, 5. I put in 2, blah, blah, churns it out. Out comes 7. I'd graph 2, 7. I would graph here 3, 9, and I'd graph here 4 and 11. Now again, I would add a negative value in there to make that particular function, but we'll see what the book has in the future. I don't know that because you guys are my first run through. Okay. So here they run through an example. 4x minus 1 equals, 4x minus 1 is the function. Use these values. I only want you to use 1 negative, 1 positive, 1 0. So go ahead and put those numbers in. 4 times a negative 2 is a negative 8. A negative 8 minus 1 is a negative 9. 4 times 0 is 0. 0 minus 1 is a negative 1. 2 times 4 is 8. 8 minus 1 is 7. So you're going to plug in, you're going to graph a negative 2, negative 9, 0 and negative 1, and 2 and 7. Okay? That's all you have to do when it comes to graphing. All right, I want you now to do the check. Press pause and do the check. Okay, hopefully you did that. And there's a learn here. Nah, no learn. Okay, good. All right, so we're going to choose the appropriate input values. Now here it's where it has to make sense. You might not need a negative input, right? Because we have to decide. So it takes approximately 770 peanuts to produce 1 jar of peanut butter. Right off the bat, no negative numbers. It'd be dumb to put a negative number in here. The total number of peanuts n is represented by the function. Here's your function. Now, determine, they want you to complete the table. So essentially, what's the question? I want you to complete the function table. So I just want you to put the values in there. That's all I want you to do. Okay. It's only blah, blah, blah. Who cares? So they want to put those numbers in. 1, 2, 3, 4. And really, let's face it. If you're going to have 4 jars of peanut butter, you're not really running a company. You want 4,000 or 4 million jars of peanut butter, right? So you put those numbers in. So I have 770 times 1, 770 times 2, 770 times 3, and 770 times 4. And this is a direct proportion. It goes to, if I put in the number 0, 770 times 0, dog, out will come 0. So that's my dog. So as you do it, understand that that's what happens. 1 times 770. So I put 1770. I put 2 in there. What's going to happen when it comes out there? Do the math. I put 3 in there. Do the math. I put 4 in there. All right. Fill that out. Finish that. And then I want you to do the check. Okay. Then do the check. Okay. So we already know how to graph. And here they'll say you can make a table chart. You could use your ordered pairs. They put it on there. Okay, so essentially, we could read these graphs to give us information. Know that when I have y equals mx plus b, like we've been graphing 1,000 times before, that is in a slope-intercept form. That is indeed a straight line. and it is indeed a function as long as it's not a vertical line. Don't forget vertical lines. If it's a vertical line, it's not a function because it fails a vertical line test. Okay, that's important to remember that, okay? Let's go ahead and let's graph. Just graph y equals x plus 2. You may use a table chart if you'd like, or you may graph using it slope-intercept form. That's totally up to you. So go ahead and graph that on your own, please. I'll press pause. Okay, hopefully you did that as well. And I lied. I want you to use the function table just once so you realize how annoying it is, okay? So if I'm doing this function table right here, I still want you to go through all of this and do this, because you could graph it easily without it. And again, I said just do one positive, one negative, N-E-G-A-T-I-V-E, and then 1, 0. As per our order of pairs, okay? So make sure you put those numbers in, and you may go, and then graph it. Press pause, and graph. Okay, lastly, we get to, and this is what I think is why we're doing this, is because I want to be able to hit our word problems. So I know you guys know how to go ahead and graph. We got the graphing down pat. A taxi service charges $2.50 plus 75 cents per mile, okay? Oh, there we go. We have it set up there. They gave us, well, that's just really dumb. If Adriana rode 10 miles in the taxi and Alonzo rode 15, how much more do they spend? Well, obviously you put it back in there, right? So if I have y equals 75 cents per mile, one person did 10, the other person did, oh, 75 cents, sorry. The other person did 15. So essentially what happens when x is 10 and when x is 15, what's it going to be? You put that in and then you find out. I'll let you guys do that. So when I did the math, and I hope it's right, I put in 10 for Adriana and 15 for Alonzo. I got $13.75 for Alonzo, which is $3.75 more than Ariana. So I think how much more did Alonzo? Alonzo, A-L-O-N-S-O, spent $3.75 more than Adriana. Okay? Always have a sentence answer with that. They've already defined our variable for us up there. X is the number of miles. Turn the page. Last one. Here we go. An elephant weighs 200 pounds at birth. That's a big elephant. And gains approximately 2 pounds per day. I'll get you, that's a 2x, right? Yep, there you go. Here's the weight of the elephant, and 2 times d plus 200. Let x equal the daily weight. I'm sorry, d equal the daily weight. Doc M's a dork. Let equal daily weight. 2d plus 200. So put that in there, okay? How much more does he weigh on day 60 than on day 5? So then obviously you have one ordered pair at 5. And then when he got bigger and fatter, hopefully, you figure that one out. Okay, I will let you figure that one out and type your answer in the space provided. Thanks. Bye-bye.